Okay, this is lesson 73 for 5th grade. And we're taking a look at the idea of adding and subtracting decimals. So when we add decimals, we just have to line up those decimal points, right? 4 and 3/10 plus 6 and 2/10 gives us 10 and 5/10. When we subtract, we need to do the same thing. If we have 5 and 5/10 minus 1 and 2/10, we subtract them and we get 4 and 3/10. Okay, that was our basic thing that we've learned in the past. But what about when we have those situations where we don't have the same amount of numbers after the decimal point? What do we do then? So let's say we have a situation where we'll look at something similar to example 3 on page 474. So let's say we're hiking a trail and we've hiked 3 and 42 hundredths of a mile, and we are going to go to the top of the mountain on the hike, and that is still another 5 and 3/10 miles to go. Okay, so let's say we have that. How much total will he go on the hike? So we want to figure that out. So we're going to add those two together, because remember that word total indicates that we have an adding together. We want to get a larger number. Remember, always ask yourself, am I looking for a smaller number than the numbers I have, or am I looking for a larger number than the numbers I have? That cuts your choices down as to what you actually would be doing. So in this situation, we take that 3 and 42 hundredths and add it to that 5 and 3/10. So 5 is here, and then I have my decimal point, and then I have that 3 over here. Now you don't have a number there. So I like to always put that place value holder just to put it so that I don't accidentally add the other one in or misalign something. So if this has 2 digits after, we're going to make sure that those have 2 spaces or 2 digits after. So we put that place value holder in there. 2 plus nothing is going to give me 2. 4 plus 3 is going to give me 7. My decimal point's there. 3 plus 5 is 8. So I have his hike being a total of 8 and 72 hundredths miles. Okay? That idea that we add up those two decimals, but we need to make sure we line up the decimal points. Don't try and do it across like this. There's more of a chance that you'll make a mistake than if you line them up underneath. Same thing goes if you're doing a subtraction problem like that. If you're doing a subtraction problem like that, we can also think of, well, let's see if we had something of 5.1 minus 2 and 34 hundredths. Well, if we have that, again, we want to put that 0 there. We put a 0 there. It doesn't change the number, just like we learned a few lessons ago, that no matter how many zeros I put after that, it does not change the value of our number. So we can now go, there's more on the floor, so we go next door. We cross out that 1, make it a 0. We break that into 10 pieces and add it to whatever we have. So we have 10. 10 minus 4 is 6. More on the floor, go next door, cross out that 5, take 1 away and make it a 4. Break that into 10 pieces, add it to what we already had. 10 minus 3 is 7. Put my decimal point in place. 4 minus 2 is 2. Now remember what I've told you in the past. We can check our subtraction by addition just like we can check our division by multiplication. So let's do our adding here. So I have 2 and 76 hundredths plus 2 and 34 hundredths. When I add those together, 6 and 4 is 10, carry my 1. 7 and 3 is 10, plus 1 more is 11, carry my 1. decimal point into place. 2 and 2 is 4, plus 1 more is 5, so we have 5 and 10 100ths. When I look at the number I have up here, 5.10, 5.10, they match, so we got our answer right. Okay, unless we have an addition error or we had a subtraction error and happen to make the same error on both sides. But that's not very common or not likely to happen. All right, so that's the idea of addition and subtraction of decimals. Now there is one I want to discuss with you, and that's example 4 in your book. Okay, because example 4 in your book talks about using compatible numbers when you're using those decimals. So I'm going to erase this here, and we're going to go on to that example, those compatible numbers. So let's see what it says. A garden snail is moving at a distance of 14 and 63 hundredths feet and moves at a rate of about 2 feet in a minute. All right, so I'm going to just stop right there, because remember what I said about things we want to write down the information we know. 14.63 feet, and that's the total distance. Okay, and then I also know that the rate equals 2 feet per minute. Okay, so there's some information that we know. Going on to the next sentence, the snail has already moved 8 and 71 feet. Okay, already moved 8.71 feet, or 8 and 71 hundredths. Estimate the length of time it will take the snail to move the remainder of the distance. Okay, so we want to see how much time will it take. Okay, so we're looking for time. All right. So we want to use compatible numbers to estimate how far the snail will still have to move. I look at the two given numbers, and we have that 8.71 and we have that 14.63. Well, it would really be nice if this part of my number, the decimal point behind the decimal point, would equal this number up here. So there's none of this regrouping or anything like that. And that's kind of what we do in compatible numbers. So we want to get that nice zeroed out on the end. So if I'm going to change this number here, I want to change it to something so I don't have to do any regrouping like I did on that other problem. So 71 is pretty close to 63. So I'm going to change that 71 to 63. We're going to leave the number before the decimal point the same. Okay, so all I've done is I've taken that 71 and I changed it to 63 because it's real close and I don't want to have any regrouping or anything like that. So this ends up in that 0 column, and then I have a 6 over here. So it has, now this isn't the end though, because remember this is talking about the feet. This is 6 feet that it still has to go. Now if it has 6 feet to go and it goes 2 feet per minute, I need to take that 6 feet and divide it into sections of 2, because there's 2 for every minute. So when I take 6 and I divide it by 2, I get 3, and that is the amount of minutes still needed to go. So let me review that again. So with compatible numbers, we want to take and have this be the same as what's back here, as long as it's close, and that's considered close. So we change it, so we have 0 over here. Then we subtract what's on the other side of the decimal point. We get 6. Now we know that there's 2 feet per minute. So I'm going to take that 6 and divide it into 2 feet sections, and that will tell me how many minutes it actually would take. So with compatible numbers, with estimating And again, remember, this is an estimate. This is not an exact. If they asked me for exact, I would get the exact. And like I've said in the past, don't take 1463 minus 871 and then round it to the nearest number. Okay, that's not the purpose of estimating, especially when you get into those huge numbers and you have to estimate. If you're going to do that, you're going to spend a lot of time trying to find your exact answer and then rounding it, and that's not what we're doing in this lesson. Okay, so remember to line up your decimal points. Remember to, if you need a 0 in a place value, put a 0 there. If there's an empty space, put a 0 there. And then use that to help you in adding and subtracting those numbers. And this would be the example to look at if you're doing compatible numbers for something like example number 4 on page 474.